Study of efficacious use of blockchain in 6G. Technology path for the future. Abstract. Since the 5G does not cope with the exceedingly high IoT demands, hence, the onus lies on 6G network to ensure that high throughput is experienced compared to the previous networks, as we see a surge in development of new facilities and applications like multiple gigabit communication rate, improved authenticity, low latency. A smart resource management along with proper distribution is necessary for achieving all the ambitions due to lack of spectrum resource, ecient resource management and sharing. Blockchain is the answer to all these expectations and has lately gained massive significance and is highly critical for 6th generation wireless network and beyond due to its smart adaptability and inbuilt features. With the help of technologies like IoT, network slicing, D2D and domain blockchain environments, we can see an enormous future for blockchain in terms of managing the resources. This review article is based on the blockchain technology reshaping the industries that brings safe production, which ensures detectability, consent, security, improved standard, and validation. We analyzed on many advantages of blockchain along with 6G and its lapses, and blockchain technology addresses daunting difficulties of 6th generation wireless network with its prospective opportunities. Keywords: 6G, blockchain, wireless blockchain, IoT. Introduction. Multi-use devices are being utilized tremendously as they support us in fulfilling our daily needs. We sense a great deal of simplicity that we, the humans, are living in a connected world via the communication networks, like internet, wireless, and mobile networks, and finally will reach the universal ecosystem. Wi-Fi communication structure is the Eureka equivalence with rapid technological developments for the past years and symmetry advancements in the IoT one. Till now, VTH generations of Wi-Fi mobile data communications systems are present. In Wi-Fi, data communication generation develops nearly in every decade since 1980s. Starting from 1981, the IST generation had the analog frequency modulation cellular system. From 1992, the IIRD generation at 2001, with the IVTH generation, which is often called as LTE, on 2011-23. In the last 10 years, a massive transformation took place in the Wi-Fi communications that led in data-demanding apps, which includes multimedia, gaming, and HD video streams, to thrive. The profitable internet technology that becomes a catalyst which enables and propagates different latest services, like shopping using mobiles and other forms of online transactions. 2.4. It's well familiar that 5th generation is itself a cell phone network. The 5G network provides a lot of channels that focuses on enabling multi-gadgets to link, as 5th generation technology depends tremendously on IoT. As we see a rise in demand for cell phones along with networks, latest Internet of Everything for users and industries has installed quickly. The arrival of SDN brings a lot of attributes which allows the network arranger and consumers to approach the network gadgets at a remote place, while grasping the international view for these places. The usage of software-defined networking technologies presents a variety of difficulties and needs solved by IoT 5. The quantity of Wi-Fi network consumers is ascending gradually because of WWW, IoT, D2D and M2M transmission, cloud-based apps, and facilities. Humans consistently want ascending uplink-downlink processing costs, better standard of facilities, improved net alongside quality of experience, improved video streaming. Hence, these requests brings massively huge cellular traffic in cell phone networks. So, latest mobile approach is needed to furnish these requests. Developers and researchers prophesied that 5th generation will be an acceptable contender in response of these requirements. 6. 5G Wi-Fi networks introduces the IoT, that depends on improved broadband approach for machine-based transmission. 7. 8. But, for 5th generation networks, since it has not been established into wider use, the aim is a long shot to be completely brought in the market. For instance, acute frequency millimeter wave connectivity and assistance in heterogeneous IoT facilities are not accessible at the limit needed for innovative usages like pervasive virtual/amplified reality or associated autonomous approach. 8. For supporting the needs of the present and future use cases, it is a necessity to go past 5G networks as it operates in a low transmission frequency bands, towards millimeter wave, which functions at a greater carrier frequencies that is originally in the high transmission frequency window greater than 20 GHz, in addition to this an even greater towards optical frequencies at the detectable and undetectable electromagnetic waves spectrum 9. Then we can witness the potential of fifth-generation networks that would be moderately divulged. The succeeding years is the transformation stage in the fifth-generation and IJERT technologies as they would trend towards forms of concurrence, wherein the usage of millimeter wave frequency will become customary. 10. The next generation of IoT would merge technologies like artificial intelligence, disseminated edge computing along with end-to-end disseminated safety assisting long binary digit rates providing enhanced mobile broadband uses. Besides the evolution of wireless connectivity at the edge of the network, we anticipate major advances also on the control and management of the edge network that will be supported by the introduction of new technology approaches driven by artificial intelligence, AI, solutions. The main aim is to improve the 5G networks with the strength of intelligence provided by cognitive calculative systems which uses large quantity of accessible data and ML algorithms. 11.9. The sixth-generation wireless network would bring in improved standards which would slowly develop and evolve and give a superior and increasingly solid network. 2. Research are performed on 6G in today's world. Sixth-generation wireless network mobile transmission technology is a demanding research area. The 6G will transform conduct, community, trade and transmission systems. It's a pivotal period to envisage the prospective applications, methods, and difficulties of sixth-generation wireless network technology. Significantly, sixth-generation wireless network will generate tremendous research prospects and allow different types of latest technologies. Sixth-generation wireless network would be a turning point in various types of .ELDs. Hence, the envisaging of the sixth-generation wireless network technology is needed to transform the contemporary world. At present, numerous nations are positioning the fifth-generation technology productively. But fifth-generation and B5G could not give the absolute necessities of the IoT. Subsequently, sixth-generation wireless network is quite demanding in the market. Analysts have commenced explaining the difficulties of beyond 5G cell phone communication. In coming 4 to 5 years, beyond 5G would develop and is extremely anticipated that sixth-generation wireless network would completely run from 2030. The sixth-generation wireless network would be an eminent .ELD of research for coming 1 to 2 decades. The sixth-generation wireless network analysis had started in Finland from 2018 and named by 6genesis.agship Project 12. On 2019, China, USA and South Korea had propelled a 6G Project 13. Japan also started sixth-generation wireless network design by 2014. NTT had issued the white paper on January 2020. Countless nations have commenced the sixth-generation wireless network project. There is a update in mobile generation every 10 years. 15. Fig.1 Benefits of 6G. 16. Sixth-generation wireless technology is anticipated to initiate various features: ultra-high security, lower latency, along with maximum efficiency inter-gadget synchronicity. 17. Hence, it inspired to explore on key matters and difficulties of sixth-generation wireless technology. The sixth-generation wireless technology will modify the clarity and approach of contemporary conduct, community, business, and transmission. It is anticipated that sixth-generation network technology will cohort in transforming different .ELDs. Sixth-generation wireless cell phone networks are contemplated to provide the prospect of ubiquitously attached data-intensive inventive society. 18. Enriched with total automation with consistent combination of all types of Wi-Fi networks on underwater, land, space and sky. 19. Sixth-generation wireless technology is visualized to maintain with the massive advancement in cell phone TRAF.C that is predicted as 607 exabyte per month by 2025 and increased to 5016 exabyte per month till 2030-20. The coming generation cell phone networks are predicted to be inherently softwareized, virtual and cloud-based systems. 18. 21. For the aim to connect coherently an astounding quantity of heterogeneous gadgets including large Internet of Things gadgets, to serve the awaited large success in data interruptions at drastically steep data rates besides the drastically small latency 19, to make magnificent scope of modern vertical network facilities 22, 21, and to assist the growth of latest collection of real-time 19 along with data-accelerated applications. Tremendous research works are being carried out in 6G networks and will continue to go on in the coming future. GUI-ETAL deliberated on different feasible uses of MBBLL, MBBMT, MLLMT23. JONG-ETAL targets on FEMBB, ERL-C, MTC, LDHMC, and ELPC24. DANG-ETAL furnishes prospective opportunities of 6th-generation wireless network 13. Besides this, researchers have written some controversial works on 6G25. Ironically, it is highly essential to discover the difficulties to be tackled by the anticipated 6th-generation technology. V. Zone-ETAL have examined the principal factors and current coherent beginning of 6th-generation wireless network 26. Z. JONG-ETAL have evaluated 6th-generation network, elaborating a cluster of encouraging methods like T-Hertz transmission, LIS, OAM, blockchain-based spectrum distribution, quantum transmission, computing, along with molecular communications. 27. R. Heath represented three principal directions in 6th-generation wireless network of the physical surface 28. P. Yang-ETAL elaborated on many modern approach of 6th-generation wireless network in the communication with network layer 29. K. Lateef-ETAL gave a developmental direction of 6th-generation wireless using AI-dependent technologies 30. F. Tarek-ETAL gave the tendency of development in 6th-generation wireless in depth 31. W. Saad-ETAL studies the different possible future problems arising from the 6th-generation wireless networks 32. K. David-ETAL 6G technology focuses on various needs of Internet of Everything 33. B. Zone-ETAL explains the development of evolving trends like ubiquitous and distributed AI 34. 3. Vulnerabilities of 6G. The difficulties in building a reliable 6th-generation wireless network are multiple ordered spanning telecommunication, rules, T, politics and conduct. A collection of the present rules, economic impetus, and development are keeping up with the present capability of hacking, deficiency of reliability, secrecy, and protection on the net. In 6th-generation wireless network, it will not satisfy as the personal integrity will completely based on IT alongside the usage for transmission over the networks. Hence, we require reliable 6th-generation wireless network. The part of reliability, protection, and secrecy are interrelated in some way or the other, but various levels of upcoming generation of networks. Some expected difficulties in the 6th-generation network are clarified in 35. Difficulties suitable to machine-to-machine transmissions are given in 36. Flexibility, physically coded protective methods can provide smart results for protecting the most integral and least analyzed network sections that are the joining the body sensors with a sync node or a hub. Latest researches are based on the highly adaptable coding facilities to be utilized for safety algorithms in 6th-generation wireless network that contain the maximum network flexibility, various types of gadgets and types of malignant attacks. The commercial Internet of Things passionate predicts that uncountable number of gadgets will be linked and functioned in the coming commercial ecosystems by the development of notions like MMTC. So it is a challenge to customize the 6th-generation wireless network systems during TRIF.C need. Integration. The integration is an important need during demanding commercial applications. The integral spine of a nation includes power-sharing systems, and automotive networks have to integrate at real time to sustain a precise operation. Verification with access restriction. The stored data needs to protect with the entry control procedure to avoid illegitimate changes. In the tremendous innovative needs expected in the 6th-generation wireless network, the standard validation and entry restriction techniques would get limited on the basis of flexibility. The latest Internet of Things gadgets with 6th-generation wireless network would ascend 10 times from 10 billion in 5th-generation wireless network to 100 billion in 6th-generation wireless networks. The economic dependency and information technology's societal impact increases due to the distribution and usage of the 6th-generation wireless networks. Real-time transmission with least latency. Real-time transmission is an integral need in the coming processing environment. The D2D and M2M transmissions need a powerful accuracy which should have nearly zero stoppages for accurate operations. A maintained low-delay transmission is needed in extensive data exchange like autonomic driving and augmented reality assistance in medical aiding systems. Accessibility. The utility accessibility is a main need in prospective networks. The fear of distributed denial of service attack is increased due to the sophisticated 6th-generation wireless network environment with a giant number of interrelated gadgets. Besides this, the 6G cannot find the breaches and dangerous attempts as the uniqueness of the present network protective tools because it cannot directly apply into the 6G network's 37. Confidentiality. The evolution with cloud framework is assumed to advance in 6th-generation wireless networks. The move towards a secure cryptography after the quantum age as wide-ranged computing is not a task to be fulfilled easily in the coming future. Current symmetric cryptography is still the most secure since quantum computing. The prospective computing framework like Internet of Things shows a large menacing behavior with Wi-Fi connection. Being light is an integral part of encryption methods such as symmetric key encryption algorithms, especially in the case of less powered Internet of Things gadgets. But this method will reveal a high privacy threat because of computational limitations. 38. Improved throughput. The main system which would use the 6G transmission environment will need synchronous connection of uncountable gadgets. The network framework like base stations would manage the large quantity of businesses at real time. Integrity. The large quantity of data made by the prospective systems would need accessibility and modification in data provided by the legitimate consumers when data is in transition. Eavesdropping along with transformation in transit data would diverge the system functionality from expectation. For prospects regarding 6G using blockchain technology, blockchain is like a clear, include-only, and sequential sections of data which is supervised by many candidates that avoid distortion. Before any addition in the blockchain, verification and acceptance of the new section of data is needed by most of the candidates. During the period of verifying, the participants need an observer of preceding data. Hence, blockchain is largely accepted like the advanced trusted mechanism for validating the 6G networks. 39, 40. Blockchain mechanism favors fragmented uses and propagation of reliability, as observed by production chains and cryptocurrency along with trusted systems. Blockchains are designed like disseminated chains that prevent one-point collapse. Till now, 6th-generation wireless network facilities could utilize blockchain guaranteeing reliability and safety, for instance in access restrictions, verification, shared key administration and evaluative deposition. 41. Hence, the predicted facilities and maximum execution of 6th-generation wireless networks improves the development with the use of blockchain, and the usage of blockchain for the facilities is predicted to enhance their rise that leads in an improved feedback loop. The blockchain propagation of reliability and safety and cloud computing provides assistance to the 6th-generation wireless network use conditions, facilities and developments. Blockchain can contribute with a distributed structure for confederated learning, removing the necessity for rationalizing command-on studying and analysis in edge-based administered ML. 42. A smart, administered cell phone network framework that is dependent at open-source Wi-Fi networks. 43. Needs an open retail in which consumers, spectrum, and ISP owners may openly involve to transfer their reserve using blockchain. 44. Blockchain is a key developmental technology to show the true capability of 6th-generation wireless network systems. For the prospective automation environment, the reserve regulation over network is a difficulty due to the predicted immense connectedness requirement. The regulation in the reserve functions like spectrum distribution, distributed calculation/analysis required adaptability with large-scale framework. Fig.2 Blockchain with 6G network. 45. V studies performed on 6G network with blockchain technology. Various studies have been carried out and are still continuing for this ever-trending subject, which is the need of the hour. Few of the key researchers on this subject are as follows. Zhang et al. 46 conferred on edge intelligence with industrial Internet of Things structure, having a reliable and adaptable service managing in post-fifth generation wireless network. Ortega et al. 47 gave a system using blockchain ensuring the coherence as Internet functions like a medium for transfer of information. Dai et al. 48 conferred the uses of blockchain along with deep augmented learning to efficiently manage the facilities, taking spectrum distribution and managing energy into consideration. Mafakri 1 et al. 49 enforced on blockchain as a resource distributor and showed that the usage of intelligent contracts would provide self-organization in networking. Yang et al. 50 provided verification using blockchain technology and coordinated procedures to provide cloud radio utilizing the .Bur network technology. Fan et al. 51 gave a safety protection scheme that was using blockchain in the content-significant networks. et al. 52 conferred an explanation on blockchain for avoiding polluting charge that harm the coherence of data. Maximiyuk et al. 53 gave a smart network framework that uses blockchain mechanism by managing the relation between providers and consumers, providing intelligent contracts. This was a without licensed spectrum distributive algorithm that dependent in the game theory. Rodriguez et al. 54 conferred a distributed denial of service prevention structure by the assistance of blockchain. Sharma et al. 55 suggested that the blockchain usability and software-defined network to enforce compelling security facilities like distributed denial of service, attack avoidance, data security, and access restraint. 6 vulnerabilities/threats of using blockchain technology in 6G. Safety risks using blockchain as an integral part of our technology would introduces us to numerous threats. 56 that are passed on to 6th generation wireless network. The types of core attacks for which blockchain becomes susceptible are as follows. Susceptibilities. Blockchain functions on providing safety and privacy with no sort of involvement of the mediators, with a mandatory agreement of most of the members. But the attackers are able to get power of the complete system by gaining the control of more than 50% of members. Using Bitcoin, an attacker needs 51% of the computation capability of the network to manage on Bitcoin network. 56. Double spending tries to forge the righteousness surrounding the blockchain's supplied ledger. Expandability because of its dissolute nature, and since Bitcoin requires a large bandwidth, computation, and repository to maintain the righteousness surrounding the ledger. Blockchain regulations needs mandatory blockages and a large quantity of transferred messages and broadcasting by the members. The throughput of any blockchain-built application on the basis of latency along with expandability could hence be prohibitive. 57. For instance, Bitcoin's highest throughput is 7 transactions per second and has a latency of 10 minutes for each verified block. Underlying networking, enabling an acceptable method in the blockchain, becomes a costly affair, and there is a substantial need for bandwidth sources. Sources are scarce in upcoming networks, hence the resource regulation for big transaction performance is paramount, as the resources needs would be tough to meet up with the present system in place. Exchange and security exploits. Blockchain is based on transparency of exchange and information. Therefore the consumer security is threatened in systems which are blockchain dependent. In addition, several attacks versus blockchain contain sel.sh mining. 58 along with Sybil attacks. 59. The prior mining is a method to access more profit and misuse the sources of honest miners using the POW mechanism. On the contrary, in the latter attack the consumer builds a collection of blockchain accounts for manipulation. So, intelligent contracts that are dependent on blockchain are increasingly broaden blockchain feasibility by enabling contracts by definition typically software-based between members like exchanges. 60. Repository. Every duplicate node in the traditional blockchain network have to compute and keep a duplicate of the finished exchanged data. This could increase the repository and calculation load on Internet of Things gadgets, that are mostly limited to the resource, thereby hindering their involvement in blockchain network. There are many obstacles surrounding the perfect functioning of blockchain technology. While there are vulnerabilities in it, there are still many reasons to be optimistic in this potentially secure technology. 7. Conclusion. Sixth-generation wireless network is an integral part of technological transmission which would provide lots of modern technologies like holographic transmission. Nevertheless, the fifth-generation wireless network and sixth-generation wireless network are significantly different. Hence, there are many difficulties of sixth-generation wireless network to maintain the necessary parameters and fulfill the prospects of this network. All controversies and difficulties surrounding the sixth-generation wireless network have been revealed from each perspective. Sixth-generation wireless network would modernize large fields and would prove a game-changer in diversified .elds. To ensure the proper resource management of 6G using blockchain, we have to tackle some challenges like execution of blockchain rules through the Wi-Fi channel and examining the basic restrictions based on the execution and safety, enriching environment on the basis of blockchain by taking into protection and different privacy matters, development of light blockchain technology for economical Internet of Things gadgets, large performance blockchain along with disseminating the industry and prospective networks. The blockchain and distributed ledger technology is one of the most disruptive technology enablers to address most of the current limitations and facilitate the functional standards of 6 guaranis. Integrated blockchain and sixth-generation wireless network would supply the network to supervise and sustain with resource usage and distributing adequately. The blockchain technology provides transparency and shared information transformation that would assist various industries. Blockchain gets a massive support by cryptocurrency along with the ledger-keeping business because of the strength of the society. 61. This technology has got increased interest by cell phone promoters decision-makers. 62.